So please take out your pencil or your pen and your paper ready for you to write as you are viewing the video, because anytime you are looking at a math video, you must be writing routinely to be practicing automatically, and that's the only way basically knowledge can be acquired, by actually putting pen and pencil to paper. So please do that now. Words translated to symbol with exponents or powers. But there's another word we can use, indice or index. Okay. Now we can recall that we said that any quantity divided by itself is equal to 1. Therefore, any quantity raised to the power of 0 is equal to 1. So we can actually write that down. Any quantity raised to the power of 0 is equal to 1. Okay, here it is. Please bear that in mind. You can even write that down now. You can scribble that on your notebook. Okay. Here we say any quantity raised to a fractional exponent or power or index can be written using the radical sign. Okay, can be written using the radical sign. Fraction is an important word in mathematics. It has a symbol. The radical sign has its symbol also. So any quantity raised to a fractional exponent, power, or index can be written using the radical sign. So take, for example, let's outline the situation. As you can see, the power here, the exponent here, is a fraction. And as a reminder, if you don't see an exponent or power, then it is 1 automatically. You can recall from that example, x divided by itself is 1. And it's 1 minus 1. X raised to the 1 minus 1. That 1 minus 1 there, as the exponent came from x being raised to the power of 1, and the 1 was not shown. So please be reminded that if you don't see an exponent like x over x, it is the same as x to the 1 divided by x raised to the 1. All right, x is the same as x to the 1. So that's where that 1 minus 1, x to the 1 minus 1 came out from the visible 1 that was there. So please be reminded of that. So here we're going to set up the situation of a fractional indice and the use of the radical sign. So as you can see, this is the radical sign. Okay, this here is the radical sign, and it has make provisions for the degree. The degree comes here in this box, and it's the denominator in the fraction. So bear that in mind. So let's say you have x raised to the n over m. So n is the numerator, m is the denominator. This can be rewritten using the radical sign. Okay. The base x will come under the radical sign, and the degree of the radical sign will be the denominator, and the exponent of x under the radical sign will be the numerator. So the numerator will be the exponent under the radical sign, and the denominator will be the degree outside of the radical sign. And here you have it. X raised to n over m. That's x under the radical sign. M is the denominator, it will become the degree, and n will be the power or the exponent of x under the radical sign. Okay? So any quantity, any quant with a fractional indice can be rewritten using the radical sign, and the numerator will be the power of that quantity, and the denominator will be the degree of the radical sign. Okay, we can abbreviate quantity as quant. So any quant raised to n over m is that same any quant under the radical sign with a power or an exponent of n, that's the numerator, and the degree of the radical sign will be the denominator. So take, for example, you have x raised to 1 over 2. That's one that's very common. So 1 is the numerator and 2 is the denominator. So since the exponent is a fraction, the radical sign can be made use of. Now x will come beneath the radical sign, and the power of x will be 1, and the denominator, this 2 will be the degree of the radical sign. Okay, so here you have it. And since the degree is 2, you can actually say square root. This is, you can read that by saying the square root of x to the 1. Now, since it is common practice to when there is a 2 as your degree of the radical sign, you don't necessarily have to write the 2. Okay, so this can be written as the square root of x. And if your exponent is 1, as we saw there already, you don't necessarily have to write the 1, an exponent of 1. So this is very common, the square root of 1, but just know that there is the square root of x. Just know that there is an invisible 2 and there is an invisible power of 1 over the x. So all in all, x raised to a half is the same as the square root of x. Okay, please write this down, and you can write it a couple of times for you to get accustomed of that, of writing x to the raised to the power of a half is the same as the square root of x. Let's say we have another example. AB raised to the power of, or exponent of 2 over 3. All right, as you can see, it's a fractional exponent. So 2 will become the power of AB, which will be under the radical sign, and 3 will be the degree of the radical sign. The denominator always becomes a degree, bear that in mind. So that will be a cube root of AB squared. All right, squared, the numerator of the fraction becomes the exponent of the base under the radical sign, and the denominator becomes the degree outside of the radical sign. So this is the cube root of AB squared. You need to be writing this routinely to be practicing so you can get accustomed to doing that. Now we have a situation, another one, when any quantity raised to a negative exponent or power can be rewritten as a denominator with a positive exponent or power. All right. So any quantity raised to a negative exponent can be rewritten as a denominator with a positive exponent. Now we may see now what coming, we're wondering what coming as the numerator. The numerator will be the coefficient. That means the number that is multiplied. Now you don't see any number that is multiplied. If you do not see a number that is multiplied, there's an invisible 1. So this 1 will come as the numerator, okay? And the denominator will be any quantity with a positive exponent, okay? So take, for example, you have x raised to the negative 1, okay? Let's say you have 6x raised to the negative 1. No, let's say 1. Let's use 1 first. X raised to the negative 1. No, you don't see a 1 in front here, but there's an invisible 1. You don't see any, if you not see any number, there's an invisible 1. So that's why you have 1 over x. All right, 1 over x. And here the invisible 1 is appearing to show that this 1 will come here, and the x now raised to the positive 1 can be just written as 1 over x. Okay, let's use an example with different numbers other than 1. So let's say we have 4x raised to the power of negative 5. All right, bear in mind the exponent has to be negative. So the 4 will come in the numerator because the 4 is multiplied, and it is not, the negative 5 is not affecting the 4. So it will still remain as 4 to the 1. Actually, that's 4 raised to the 1. So 4 raised to the 1 will remain as 4 raised to the 1. Now the x to the negative 5 will come in the denominator, and the 5 becomes positive. Okay, so they call that any quantity with a negative exponent can be rewritten in the denominator and the exponent becomes positive. But the coefficient that is multiplied to that expression will remain as the numerator. It will remain as is. 4 raised to the 1 will remain as 4 raised to the 1. There's a 1 there. 1 raised to the 1 will remain as 1 raised to the 1. And actually, this was an invisible, that negative 1 would have become a positive 1. And that's why we just write it as 1 over x, because if you don't see a power, it is 1. If you have a power of 1, you don't have to write it. Okay? So please be practicing that. Fractional indices, fractional exponents, here they are, and negative exponents, here they are.